Welcome back to Lesson 4 of the e-learning course 0 Basics of Finance. In session 4.2, we will study another method to evaluate investment projects. The method is called the internal rate of return and is used frequently in finance. The learning goal of session 4.2 is to introduce you to the internal rate of return, IIR for short. As you will see, the IIR can be a handy measure, but it can also be a misleading measure. You should therefore know how to calculate it and how to use it properly. From a conceptual perspective, it is straightforward to understand the internal rate of return. The IIR is the discount rate that makes the net present value equal to 0. Computationally, the IIR can be found by an iterative root-finding method like Newton-Raphson. However, simple spreadsheet programs like Excel have built-in functions to compute the internal rate of return very easily. The corresponding Excel function is called IIR. It is important that you don't confuse the internal rate of return with the opportunity cost of capital. The IIR is a profitability measure that depends solely on the amount and time of the project cash flows, while the opportunity cost of capital is the expected rate of return offered by other assets with the same risk as the project being evaluated. The decision rule when using the IIR is to accept a project if the opportunity cost of capital R is less than the internal rate of return. Let's assume that the IRR is 28.08%. This means the project has a positive net present value if R is less than 28.08%. Accordingly, if R equals IRR, the NPV equals 0, and if R exceeds the internal rate of return, the NPV is negative. By comparing the opportunity cost of capital with the IIR, we are in fact asking if the project has a positive net present value. However, it is important to note that the IIR rule only gives the same answer as the NPV rule when the NPV is a smoothly declining function of the discount rate. Now let's have a look at some pitfalls related to investment decisions based on the internal rate of return. It might be the case that not all cash flow streams have NPVs that decline as the discount rate increases. To illustrate this scenario, consider the following projects, A and B, where each project has an IRR of 50%. Do you think that these projects are equally attractive? Obviously not, since in the case of A, where we're initially paying out $1,000, we are lending money at 50%, while in the case of B, we are initially receiving money, which means we borrow at 50%. The conclusion to be drawn is when we lend money, we want a high rate of return, and when we borrow money, we want a low rate of return. For project B, it follows that the NPV increases as the discount rate increases, which implies that we have to look for an IRR less than the opportunity cost of capital. Another pitfall is related to the case where multiple rate of returns occur. Suppose the development of a new mine in Western Australia involves an initial investment of 30 billion Australian dollars and produces a cash flow of 10 billion a year for the next 9 years. At the end of that time, the company will incur 65 billion of cleanup costs. First of all, note that there are two discount rates that make the NPV equal to 0. The figure shows how this comes about. As the discount rate increases, NPV initially rises and then declines. The reason for this is a double change in the sign of the cash flow, once in year 1 from negative to positive and once in year 10 from positive to negative. In general, there can be as many IRRs for the project as there are changes in the sign of cash flows. This comes from a mathematical fact called Descartes' rule of signs. Whenever the cash flow stream is expected to change sign more than once, the company sees more than one IRR. Very often, firms have to choose between mutually exclusive projects, meaning they have to choose between several alternative ways of doing the same job or using the same facility. In this example, think of project D as manually controlled machine tool and project E is the same tool with the addition of computer control. Both projects are good investments. However, if you follow the IRR rule, you're supposed to choose project D, and if you follow the net present value rule, assuming capital cost of 10%, E has the higher NPV and seems the better investment. In order to salvage the IRR rule, we can look at the incremental cash flows. This means when doing project E, we have additional investment costs of $10,000, which generates additional cash flows of $15,000. The internal rate of return is 50% and thus well above the opportunity cost of capital of 10%. This implies you should prefer project E over project D. Now let's look at a similar example as before, but note that this time the two projects offer different patterns of cash flows over time. Moreover, we assume again that only one project, F or G, can be undertaken. Plotting NPV as a function of the discount rate shows that project F has an internal rate of return of 33% and project G offers an internal rate of return of 15.6%. The NPV at capital cost of 10% is $3,592 for F and $9,000 for G. Using again the incremental cash flow approach, it follows that project G has a higher NPV as long as the opportunity cost of capital is less than 15.6%. The reason for this is that total cash flow of G are larger but tend to occur later. Discounting at a lower rate then implies that G has a higher NPV. However, if discount rates are high, investors will place a higher value on the shorter-lived project F. Another important question to consider comes up when there is more than one opportunity cost of capital. So far, we have assumed that the opportunity cost of capital is the same for all the cash flows. For example, in an economy where the term structure of interest is not flat, differences between short and long-term interest rates can be important. However, the extra precision from building the term structure of interest rates into discount rates for risky investment projects is rarely worth the trouble. More important in this context is to make accurate forecasts of future cash flows, since more precise cash flow projections outweigh the gains from precise discounting. What conclusion can be drawn on using the internal rate of return? For investment projects with an initial cash outflow followed by a series of cash inflows, there is no difficulty in using the IRR to decide where to accept or reject a project. However, looking for the project with the highest IRR rather than the highest net present value can lead to flawed decisions. As illustrated in Pitfall 3, short-lived projects requiring little upfront investment usually have a high IRR. However, such projects may not add much to the value of the firm. After having carefully studied session 4.2, please start with the review questions.